In the last video, we established that the logarithm is the inverse function to the exponential function. A consequence was we were able to graph the logarithm. Using the graph of the exponential function, if we just flip it across the line y equals x, because it's the inverse, we will get the logarithm function. Let me talk about some more consequences of the logarithm being the inverse function to the exponential function. The first consequence is the domain and range. So we have that the domain of the exponential function is everything, and the range of the exponential function is all positive numbers. The range over here is all positive numbers. Okay. So cool fact about inverse functions is that the domain and range are exactly swapped. So this is going to be the range of the logarithm function. And this range of the exponential function, that will be the domain of the logarithm function. Or if you prefer, instead of relying on this abstract framework here, you can just look at the graph over here. The domain of this logarithm function is all the x values, all the inputs. All the inputs is everything greater than 0. Whereas the range is all the outputs, and it looks like everything is outputted in the for a logarithm. Okay, so that's the first consequence of this inverse function. The second consequence is the what this is in the definition of the logarithm being the inverse of b to the power of something, which is that the logarithm base b of b to the power of x equals to x, and b to the power of the logarithm base b of x equals x. So these are properties that are satisfied and are equivalent to functions being inverse functions. Okay. These make sense. These are true exactly when they make sense. So this is true. B to the power is something that always makes sense. This is true always. And this is true whenever it makes sense. You can take the logarithm of something when your number is between 0 and infinity.